Live streaming from Automate, it's Matt Kirkner, your host for the Tech Ed Podcast. 25,000 decision makers, engineers, technicians, and curious explorers walking through the aisles here at Automate all week. We're in Detroit, Michigan. It's absolutely phenomenal. All the automation technology on display, 750 different exhibitors with their products on offer. And of course, we are in the FANUC Education Pavilion. For those of you who don't know FANUC, and I think pretty much everyone knows FANUC, the world's leader in automation for manufacturing, including robotics, CNC, motion control, and robo-machine solutions. So great times are had by all here at Automate. We're well into the afternoon talking with all kinds of fascinating guests, and today's guest, our next guest, is absolutely no exception. He's a great friend of mine, a great friend of the Tech Ed Podcast. His name is Joe Steele. He is the Vice President of Communications and Legislative Affairs for Lyft. We are going to learn all about Lyft, and they're just doing amazing things for innovation, amazing things for manufacturing technology, for our next generation of manufacturing technicians and experts and so on. We're going to learn all about that. Joe, welcome to the Tech Ed Podcast.
Yeah, thank you so much for having me. I hope to be as fascinating as you sold that to be. So, but yeah, looking forward to the conversation. Great to be here in Detroit, about 2 miles away from our headquarters. So, yeah, thanks for having me.
Yeah, you travel all over the world. You mentioned you're going to be in Washington, D.C. here in another few weeks. And you and I think the last time we were together was in La Crosse, Wisconsin,
right.
Which is a little hole in the corner of Wisconsin that is just a beautiful area right there on the Mississippi River. We were spending some time with Western Technical College, I think,
Right.
just absolutely beautiful. So it's great to be with you again. You get around, but it's nice to be at a show where you're only a couple miles away from home.
Oh yeah. Don't have to sleep at night in a hotel. Can go home to my own bed. Was in my office this morning, so it works out well.
Life is good this week for Joe Steele.
Right. Yeah, exactly.
Yeah, absolutely. And life is good with the Manufacturing USA Institutes. We've had a number of your other institutes on with us. We were at IMTS and live streaming there at that show, and a number of the folks streamed through the podcast booth. But just for a reminder for our viewers who may not be completely familiar with the Manufacturing Institutes, before we get into the nuts and bolts of Lyft, what
Sure.
are the institutes?
Well, the institutes, we are all, there's 16 of us now. We're all National Manufacturing Innovation Institutes. There are 9 of us that are supported and sponsored and work with the Department of Defense in some way, shape, or form. There are 6 that are sponsored by the Department of Energy, and 1 that is sponsored by the Department of Commerce. So we are all, independently operated and working in our own technology lanes, but we all have the same mission in mind, which is to advance technology on behalf of the American, national industrial base. And for Lyft and their other DoD institutes, we are looking to drive innovation into not only the manufacturing base, but also into the hands of the warfighter, so they can utilize this manufacturing innovation, these innovations as quickly as possible. We want to make sure, all of us collectively want to make sure that the U.S. manufacturing industrial base is secure. Our supply lines are secure, and what the warfighter needs, what our industrial base needs. We want to make sure those are all manufactured here in this country. We've seen, particularly over the last couple of years with the COVID pandemic, what happens when supply lines are disrupted, and we want to make sure that doesn't happen. Particularly as things as important, as critical as the items our warfighter needs. So we're all driving towards the same mission, because our national economy rests on the manufacturing base, and with the national economy, so goes our national security. So really, we're driving national security at the same time.
I love that answer because it really speaks to the fundamental importance of American manufacturing. And who would have guessed here, 10, 12 years ago when the Obama administration was standing up the institutes, that we'd be sitting here in a world where we've lived through a huge supply chain disruption that
Right.
maybe nobody predicted or expected when some of this innovation was going on 10, 12 years ago. And we're now on the back end of that, although we're still
Right.
faced with a lot of challenges. Lots of manufacturing coming back to the United States of America, which I think is absolutely fantastic. And coming back to a world that is a lot different when that manufacturing left over the course of the last 20 or 30 years.
Yeah.
It's highly automated. It's highly data-driven. The jobs are way more fulfilling, I would argue, as someone who ran manufacturing companies for 20-plus years over the course of a career in manufacturing. Way more interesting. They're safer. It's just a great time to be in manufacturing. And as you think about those different lanes that the manufacturing institutes, Manufacturing USA institutes are in, Joe, tell us specifically about the lane that Lyft is in, your specific institute.
Yeah, so we work at the intersection of materials, research, manufacturing process, and systems engineering. And along with the technology, we want to make sure we prepare the workforce to work with these new innovations when they hit the shop floor so that we don't create another skills gap.
Right.
Everyone's heard of the skills gap that exists right now. We don't
Right.
want to create another one as we're developing new innovations. So we are working, everything is materials, right? Everything you see around us at the show, all the vehicles everyone drove in here today, all the booths are made up of materials.
Sure.
And we want to make sure that we understand these materials, because as different processes become available, talk of additive manufacturing, particularly on the metal side, we want to better understand those materials, to know that they're fit for purpose at the end of the day.
Right.
To know that if I print something, if I make something, that it can be utilized for what we intended it to be used for. So we are deep into virtual modeling and simulation of those materials and those processes to validate the physical world. We
Right.
want to marry the two, the virtual and the physical, so that when something does come off the printer, it matches our virtual predictions, and that we know that it's ready to go. So working on things like hypersonics, for example, you see that in the news, you hear about it in the news. Those things are going 5,000 miles an hour.
Right.
We want to understand what we need to make those out of, and then
Right.
how do we make it. And as we develop these new materials, how do we join them together in a way that makes sense, so these vehicles can go from point A to point B without falling apart, without melting? How do we create them in a way that is efficient, that is effective, and are ready to go when they come off the printer, if you will? So that's just an example of what we are doing. So we are deep into, again, the ICME, Integrated Computational Materials Engineering, which is the virtual modeling and simulation, the predictability, the prediction of materials and how they'll react. So in our facility that's 2 miles down the road, we can make a new material every day of the week.
Huh.
But to understand what it can be used for,
Right.
to understand that, okay, this is the intent. Does it meet that intent, or do we need to change the recipe a little bit? Do we
Right.
need a little more of this, a little less of that, to make sure that it's ready to go when it comes off? We won't call that born certified. It is certified and ready to go when it comes off the printer.
It's one of those things that we work in and around every day, right? Whether it's the material that our phone enclosure is made out of, the body of our vehicle.
Yeah.
To your point, some of the just amazing technology that exists in the world of defense. It's easy to forget how important materials are, right?
Oh yeah, I mean some of the experienced, I won't say older, some of the experienced engineers that I work with,
Yeah.
they will tell you, decades ago, not even that long ago, there'd be a lookup table.
Yeah.
I need to make this, so you look it up, and okay, this material will fit that purpose. But now we're in a world where, as I mentioned, with additive and other processes, that we can just create new materials. So we have to understand them,
Right.
And that's really where we are, and that will help enable, new technologies, as I mentioned, hypersonics, but can we make armor for our DoD, our warfighters that is lighter,
Right.
but just as strong or stronger,
Sure.
so they can be more maneuverable, safer, things like that. So it's an exciting time to be kind of living on that cutting edge of what's next.
For sure. Well, and you think about, in so many ways, our national security and our very way of life and our freedom here in the United States relies on our ability to continue to innovate, to continue to have a strong position from a defense standpoint. And that's the kind of research that you and your colleagues are doing right there at Lyft, again, 2 miles from where we sit here at Huntington Place in Detroit.
Right.
Can you go a little deeper on some of the research? Now, I've full disclosure, I've been through your facility. It's absolutely fascinating. I
Yeah.
still remember the NDA that I had to sign in order to get back behind like the third level of security to see what's going on there. And I'm going to live by that, so I'm not going to speak to any of the things that I saw while I was there. But
Yeah.
are there some examples or some things that you can share in more detail with our listeners and our viewers about some of the research that's taking place at Lyft?
Sure. So, as I mentioned, we've got a facility here in Detroit that's about 2 miles away from where we are now. 2 miles away from downtown Detroit, the heartbeat of American manufacturing. Over the course of time, and was once upon a time the arsenal of democracy here in Southeast Michigan.
Arsenal of Democracy.
Yes,
I like that. Is that original?
Yes. No, it was in World War II when we were
Okay.
the auto industry pivoted to help support the war effort, and we started cranking out planes and started cranking out tanks and things like that. So they were asked by the Department of Defense, can you do this? And we had the infrastructure in place in terms of assembly to do that. And not too far away, Willow Run, we were cranking out airplanes during World War II. So kind of awesome. Yeah.
The arsenal of democracy.
Exactly.
Sorry to interrupt.
Oh, no problem. So our facility is 100,000 square foot facility of high-end manufacturing equipment. We've got $50 million worth of equipment that's back there.
Wow.
We do, kind of have an open door policy these days where we have, 5,000, 7,500 visitors a year that come through to take a look and see what we have going on. But it's all about materials research and manufacturing process. So back there we've got, we've got a giant extrusion press to understand what happens to this material as it's being extruded. How does it change, right? Can it, again, everything with the idea of, is it fit for the intended purpose at the end of the day? We've got our virtual modeling and simulation lab that's there where we do the materials, the ICME work with the materials and manufacturing process. And we take it to our EOS laser beam powder bed fusion machine to actually print a sample material, which then goes and gets tested. We've got the wire arc additive manufacturing. Can we use welding arms to just lay beads of weld on top of each other and then machine them down into a component? Incremental sheet forming instead of a giant stamping press. Can I take a robot? Here we are, automate. Can I take a robot, arm it with a stylus, and just trace out a piece with pushing the sheet metal down and pushing it around? You can imagine something like that being used. If I crack an oil pan in my Humvee and I'm in a forward position, can I just make one? Yeah. Versus having to take that vehicle out of commission. But again, it's about understanding the materials. How far can I push that material before it cracks, before it becomes compromised in some way, shape, or form? And we're always at the cutting edge in that facility. We opened up our high bay in 2017. We've been around as an institute. We're one of the oldest of the 16. Mm-hmm. We've been around for 9 years now. Opened that high bay in 2017, and you look at it now. It'll be much different if you look at it 6 months from now, right? And it looks much different than it was 6 months ago. So we're always moving with ourselves and understanding what the DoD needs, understanding what our industry partners need. We've got 340 members around the country, right? So not everything's done in our facility, but we've got a lot of stuff that's going on in our facility each and every day. So just a quick sample. So come visit us at lift.technology, and you can actually do a virtual tour of the place. And if you're in Detroit, please stop by.
Absolutely. As I remember from the last time, and that I've been there, as I mentioned several times, some of these research projects, and it's hard to kind of get a sense for the scope and the size of 100,000 square feet of research that is taking place there. But they revolve a little bit over time in terms of partners and projects, if I recall correctly. Is that right?
Yeah. I mean, we were born as an institute that focused on metallics only, and with a focus on making things lighter. On lightweighting. But as we grew, we understood that that was a bit of a narrow scope for us to operate in, and we wanted to get a little bit wider. So we started to look at a broader range of materials and beyond just lightweighting, because lightweighting is inherent in the materials choice, in the design choice, and so it kind of is a part of what we do each and every day.
But you sacrifice some other properties when you do, right?
Sure. So we've got projects going on in our facility for the Army where we're on the rotating bands that are the bottom of projectiles that hold the pressure underneath them. Those things cracked. And is it a materials problem? Is it a application problem? How the band is attached to the projectile? Because we want to make sure these things can go further, make sure they can go straighter, right? And because the further we are away from the bad guys, the better. So we're working on that.
That's a good life lesson, by the way.
Exactly.
Not just in national defense, but pretty much on the element of life.
Right. We've got the hypersonics work that I mentioned, and then some other things we're working on. We're going to start kind of making batches of our own materials, because we realized there was some supply chain issues when we had some welding projects for the Army. We couldn't find some of the welding wire we needed in this country. Wow. Which speaks to why we exist.
Yep, for sure.
And we had to source it from overseas, and it wasn't good quality. So, okay, great. There's a gap there. Should we then fill it in the meantime, before while we're trying to work with our ecosystem to build it out across the country. There's a project that we're going to be kicking off here shortly in the fuel cell area for drones.
Wow.
Which again, the supplier of the fuel cells was purchased by a Chinese company, and that is a no-go for the Department of Defense. So they needed a new supplier. So we're going to build out a pilot line to see if we can build these fuel cells. In the meantime, find a alternative supplier, a permanent supplier for the DoD. So any number of projects going on at our facility, and always growing and changing. And as projects complete, new projects come on. It's pretty awesome.
Absolutely. One, and it just provides a real insight into the future of manufacturing technology, the future of materials technology. It is going to continue to evolve. We're here in Michigan with so many things happening in the mobility sector. Obviously, and the fuel cell world, you're driving some of that. So it really is an exciting time to be working in the world of manufacturing, working in the world of materials, and I would argue an even more exciting time to be a young person figuring out our next steps in our career pathway.
Yeah.
One of the things that I've seen, and again, having been in your facility several times, is the work you're doing at the Lift Learning Lab, which is just, if people haven't experienced that, the way that young people, and I would argue the young people who are in most need of that type of inspiration, are being reached by the programs, it really is just fascinating. So let's talk a little bit about, in as much as we're here in the FANUC Education Pavilion. I know FANUC, by the way, is a great partner of Lift, among others. Tell us about the Lift Learning Lab and the inspiration and the training and learning that's happening there.
Yeah, thank you for bringing that up, because I didn't get a chance to bring that up talking about the facility. So the Learning Lab is perched in the mezzanine of our high bay. So students come in each and every day to participate in a curriculum that we developed called Ignite Mastering Manufacturing. That's for high school students.
Yep.
It's a 3-year program that we teach out of our Learning Lab, but we're also working with our partner Amatrol to roll it out across the nation. There's about 4,000 students that participate in that program each and every day.
Awesome.
Both in Detroit and around the country. But our Learning Lab is where we develop the curriculum. It is our the whole high bay is our pilot area, right?
Yep.
Where where we're testing new things, building new things, and that's where we develop the curriculum to really engage students at a foundational level across manufacturing. So it's not specific to what we do, but it's just broadly manufacturing, where they get to look at electronics, get to look at automation, get to look at pneumatics, get to look at things like that. So they do some work hybrid, they do some work online, but then they also come to our facility and get the hands-on equipment. Meanwhile, they're perched on the mezzanine of our high base and look out the window, and they see all the stuff we just mentioned previously, which was, they see the WAM cell that's up and running. They see the incremental sheet forming. They see our technicians. They see our engineers. They see our ecosystem working. And it's almost learning by osmosis at that point, right? Because they can see the future. They can see that it's clean. They can see that it's smart. They can see it's digital.
Right.
They can see that it is, maybe they didn't know what to expect, or maybe they had an old version of manufacturing stuck in their head, and gives them opportunity to kind of see what it looks like, because that's why we have an open door policy, not just for the students, but for people in general, because we want people to see what manufacturing looks like in 2023.
Absolutely.
And to see that it's super smart. It is clean, and there's really innovative stuff going on. So that's our high school students. We also bring any number of field trips through, day-long STEM activities, etc., coming through for our local Detroit area students.
Right.
But we also provide some skilled trades certification programs there in welding, CNC, industrial technology, maintenance, and robotics, for our adult learners, folks who may be looking for a new skill, looking to reskill, and they have an opportunity to earn a industry-recognized nationally portable credential right then and there.
It's so important as we look at the evolving face of education and the importance of stackable credentials, that we can gain skills all kinds of ways. We can demonstrate that we have those skills all kinds of ways, and a third-party independent credential is a great way to do that. I reflected on some of the students that I saw the last time I was in your facility. And certainly they're learning about materials, and that's really important. And then on top of that, through your Ignite program, learning about things like basic AC/DC circuits, learning about fluid power, about relay control, about programming PLCs, about entire manufacturing operations. And we see education evolving from, we used to just teach the theory, right? And
Right.
then, we used to teach physics and we would teach calculus, and you'd have students wondering, what am I going to use this for? Now you walk into a facility like Lyft and they can see the applied technology. They can see the applied use on the hands-on trainers. You mentioned the partnership with Amatrol. I'm a big fan of Paul Perkins and his team and the work that
he's
they're
great.
doing.
Yeah.
He's literally leading the country into the future of industrial training in a really, really great way. But then to take it one step further and not only learning on the hands-on trainers, which provide awesome hands-on skills training, but then being able to look out the window over that mezzanine, all that equipment, seeing adults, seeing people who are in the workforce working on that technology. I mean, it really connects the dots from the student, from the theory to the hands-on learning to the application in a way that I'm not sure too many other places do.
Yeah, I mean it's a tremendous opportunity. It's not their classroom. It's not anywhere. It's not anywhere else. It's immersive, and it is a unique facility. And we've been able to, Siemens, for example, one of our members has served as mentors for some of our students in some of the programs to have conversations about, okay, how do I become an engineer? How do I end up where you are at global corporation like Siemens is having a tremendous impact on manufacturing and tremendous impact on the world. How do I get from where I am to where you are, and what does that path look like? And having those conversations with a third party, as I mentioned, it's not their teacher, it's not their instructor, it's not their parents. Right. It is from somebody that is living and doing it each and every day. So having them engaged in our facility with our ecosystem will provide tremendous benefits. And we know all of them aren't going to go into be a technician, or not all of them are going to go become engineers, but some of them will.
Yeah, and at least they know that's a job they could have.
Exactly, and kind of know what it looks like, so they can make that decision. Or they might not have had any idea. There was a story of a woman, girl who was interested in becoming a hairdresser, but then came to our facility and said, "You know what? I'm going to be a welder."
Yeah, I love it. Great.
And just
working with her hands, creating the future.
Yeah, exactly.
Yeah,
completely had something that she may not have ever seen.
Yep.
But the opportunity exists, and it's the opportunity to show them what that future could look like.
I have a really good friend in the form of Tim Sheehy, who is he's the president of the Metropolitan Milwaukee Chamber of Commerce, and his line is, "If I can't see it, I can't be it."
Yeah,
and
exactly.
and you're giving these students the opportunity to see what the future can look like, and they're also understanding your incredible relationship with the Department of Defense and so on. That's really, really important as they're going through this process. Let's reflect on that a little bit. One of the projects that you and I have been involved in to some degree is this whole idea of how we take individuals. You use the term warfighter, and I think that's a really good way of characterizing in some ways how people serving in our nation's military, characterizing the important work that they do. They really are, many of them on the front lines, making sure that we can preserve our freedom and our way of life here in the United States. They get to a point in their careers, many of them, most of them, where it's time to transition to something new.
Right.
Their military service is ending. That could be a really tough transition, in as much as there's great technologies, lots of discipline that they're learning. One of the things we hear from our nation's veterans is, as they transition from the military into the private sector, into civil service and so on, there's things that they need to learn during that transition. Talk a little bit about the work that Lyft is doing in those endeavors.
Yeah, so one of the programs we're most proud of is Operation Next, which was born we launched as a pilot at Fort Campbell, Kentucky, to say, okay, can we give these soldiers an opportunity, these service members an opportunity 6 months before they separate from active duty to earn one of these nationally portable, industry-recognized credentials in those same 4 majors that I mentioned? And it was tremendously successful. 90+% of these folks immediately went on into industry after leaving the gates, because it was important to us as the Department of Defense Manufacturing Innovation Institute to not say, okay, good luck, thanks for your service, good luck in finding a job. It was, when you leave the gates, you have this credential in your hands. And it was good luck because you're already, into industry, right? Give them an opportunity because they had served our nation so well and so bravely. So that program was super successful. We've since been rolling it out around the country. It's available in 14 locations now across the country, all the way from Hawaii to here in Michigan, from New York down to Puerto Rico. It is available for service members, and we've expanded it to National Guard and Reserve members.
Awesome.
Often forgotten members of our armed forces. Their spouses and immediate family members who, again, have also sacrificed.
Yep.
In terms of their spouse being a part of the military, they might be underemployed, unemployed, or just looking for a new skill. And there's some instances where we've rolled it out to civilians as well, because that skills gap is so critically important to fill. So it is a tremendously it's a program that we are super proud of.
Yep.
And excited to get as many people as we can in the program. So you can check that out at opnextjobs.com or get to it from lift.technology, either way, but we'd be happy to talk to you about it.
I'm a huge personal fan of the work that Operation Next is doing.
Yeah.
And when you and I were together in lacrosse, it was actually standing up
Lacrosse,
brand new
yeah.
and announcing a partnership between Western Technical College, the Wisconsin National Guard, led by Major General Paul Knapp, the Adjutant General of the National Guard in Wisconsin, who's a good personal friend of mine, and was just a really, really rewarding time where you think about these individuals who are not only able to transition into private enterprise, into manufacturing and industry following their service to our country, but gain those skills in the last 6 months while they're serving, so that they literally come out of the service job ready with skills that are in high demand, step right into a career.
And sometimes it's not even learning those skills, because I've been able to talk to some of these service members as they're in the program. All of our skilled trades programs are skills based,
right?
So it's not just and they're self-paced.
Yep.
So
competency-based
it's not
training.
just getting butts in seats for X amount of weeks.
Exactly.
So some of these folks I talked to, they learned welding
right
because they had to.
Yeah.
In the service. But they just needed to. Oh, I need my vehicle's broke down. I need to get from point A to point B. So let me fix this real quick.
Yep.
But now they're understanding the reason, the science behind it, and actually getting the credential paperwork. So if you come in with some experience and some knowledge, you can move faster through the program, and that puts you on the path to a in-demand job that much quicker.
It really speaks to the importance of competency-based learning, which is another huge trend in education, where we see individuals. It doesn't matter, to your point, how long you sat in a classroom. You know, you don't have to check the box of how many hours you had of learning. Can you do it or can't you?
Right.
Do you know it or don't you? And then let's get on to the next thing. And I think that is a huge trend that we are seeing in education. It's something that you responded to really well in terms of designing the curriculum and the experience for Operation Next. Speaking of trends, we're seeing all kinds of really cool trends here at Automate, and would be curious, Joe, as you look at the world of materials, you look at the world of innovation, of research, and so on, are there specific trends that you are seeing that you think we need to be thinking about as we look at the next steps in terms of innovation and in terms of upskilling?
Yeah, that's interesting. I think a couple of things. One is the connectivity. Machines essentially talking to each other,
right?
And that goes to the digitalization of manufacturing.
Totally.
We talked previously about how clean it is and how smart it is, and that goes to the trends, right? These machines are talking to each other, working alongside humans. Everyone's talking these days about AI and the role that's going to play in the future, and how, what is that going to look like for manufacturing. So I think it's the combination of connectivity, communication, I guess, from machine to machine, from machine to human, and then just the digitalization of it all, and that's partly where. Not to go back to Lyft and the work that we're doing, but that's part of what we're trying to achieve with our modeling and simulation work, which is, can we understand what's happening to a material as it's being processed and make those changes in situ? So we're understanding the environment we're operating in. We're understanding the material as it's being worked. Can we make those changes right now? Which again, accelerating. We're all about accelerating these manufacturing technologies so they can be used faster, so they can be done more efficiently, and we can move the U.S. We don't want to make incremental changes,
right?
We want to make transformational changes.
Transformation, you got
and
it.
That's the only way that we can surpass our global adversaries, our global competitors. You can't catch up to them and surpass them by incremental changes.
Right.
You need to leapfrog and make transformational changes. That's where we are, and I think that the trend of AI, the trend of communications amongst machines, while previously might have been science fiction, I think it's I think we're headed in that direction.
And in some ways, we're already there. And you just walk around this conference here at Automate and see all the different technologies you mentioned, artificial intelligence, all the IoT, the connectivity, the digitization of data, and your use of that at Lyft. And I think that's a really important observation. Is the smarter we can make our processes, the more we can gather information real time, the more we can perform real time testing, and to your point, really accelerate innovation.
Right.
And I'm with you. I'm all about let's not make these one step at a time changes, because I can tell you our global adversaries are not thinking that way. They're thinking in terms of step transformation, and if we're not thinking the same way, then we're going to be left behind. And if we are thinking the same way, I think there's a lot of reason for optimism, and we're seeing a lot of that optimism here at Automate. I want to end our time with Joe Steele, who's the Vice President of Communications and Legislative Affairs for Lyft. With one final question, Joe, and it is a question that we ask every one of our guests on the Tech Ed podcast, and we get so many amazing answers. I'm sure yours will be no different. But if you were to go back in time to that 15-year-old Joe Steele, you're a sophomore in high school, your whole life is ahead of you, and you could give that young man one piece of advice, what would it be?
Oh man, my son is 15 right now, so it's like going back and exactly. So it kind of fits. I would focus more on, like I said, the importance that manufacturing plays in the U.S. economy and the U.S. national security. Learn how to make things. Learn what things are made of. And understand how that works. This is I've been with Lyft for 7 years now. And it's really my first stop in manufacturing. So over these last 7 years, I've learned so much from the people I work with, the people in our ecosystem about manufacturing, coming to conferences like this, having discussions like this, meeting folks that are here and involved in the manufacturing sector, but understanding how things are made, what they're made out of, and the important role that plays in our national security. I don't talking about a 15-year-old to understand national security, but it's important how much. Especially here in Detroit, how much of our population relies on manufacturers, employed by manufacturers, and across the nation, and the important role that plays to, having a manufacturing and production economy versus a service-based economy, and how important it is to be making things as a nation. I think I would try to get that across to a 15-year-old. How do we make things and go tinker and make some
absolutely.
things.
No, I totally agree with you. I insisted. I've got two kids, and they're a little bit older than yours are, but certainly than your 15-year-old. But one of the things I insisted was that they work in manufacturing for at least part of what we said we'll help you out with whatever comes after high school. But the price you're going to pay is you're going to work in a manufacturing facility. You're going to learn about the amazing people that work in manufacturing day in and day out, all the innovation, how it touches every aspect of our lives in ways that we see every day, and more important, lots of ways that we don't see, but that happen and are really, really important. So I like that idea. Learn how to make things. I'm glad you learned how to make some time here for us on the Tech Ed podcast. Joe Steele from Lyft, Vice President of Communications and Legislative Affairs. It's been wonderful spending time with you, and thank you for joining us.
Yeah, thank you so much. Appreciate the opportunity. I look forward to next time.
Yep, we'll have you back for sure.
All right.